sound? Was that coming through the projector? Interesting. It's always interesting where the sounds come from. All right, let's take a look at number 6. See if I can do that one. I also want to grab here. Let's see. Partner quiz key. All right, we'll see if I can figure it out from the key here. All right, so we know that it is an improper integral. It's very obvious when it has an infinity symbol on it, right? The ones that you guys I noticed were struggling with a little bit more were the ones where we didn't have an infinity, where it was another discontinuity. It was like maybe instead of having if it looks more like this, the integral from like 0, not 0. Let's not do 0. So this is a what if. This is the one I was noticing as we were working this week, like -1 to like 10, 1 over x plus 1, where you put this in and there's some kind of discontinuity. So you guys need to watch that. I was noticing that as we were doing the board work this week. We were struggling seeing it that way, okay? So just be careful, okay? That one would have been an improper integral, all right? All right, let's take a look at... and I'm in Cami, not OneNote, because my this computer doesn't like OneNote right now. All right, they all have their own personalities, don't they? All right, so we're going to start improper integrals. We go limit as b approaches infinity from 0 to b of 1 over 9 minus or plus x squared dx. Okay. I don't know why they did it that way. Okay, so this one's a little bit weird. They did it with trying to get, I'm not sure the exact explanation why, but I'm assuming we tried to do it just with an arctangent or a tangent inverse right away, right? Where you use the A and the C. Because I don't think it has to be 1. The way that they did it is weird. All right, let's try it our way, and then we'll see if I really need to do it the way they're doing it. Okay, let's see if I can get to their pi over 6 answer. All right, arctangent of, I'm just looking at theirs one more time. Arctangent of 1/3. Yeah, they did all kinds of weird things. Okay, so when we do this, we know that this is the A value and that's the U value, right? So when we're doing, because it definitely looks like an arctangent, right? So the limit as b approaches infinity of, so arctangent is 1 over A out front. So what would we get out front? 1 over, it would be 3, right? Not 9. Because that's A squared. But I totally wrote the 9, didn't I? All right, 1 over 3. And then it's arctangent. What's our U? X, and then over A, which is 3, okay, from 0 to B. Okay, so keep following the rules. Let's put this in. So we've got the limit as B approaches infinity of 1/3 arctangent of B over 3 minus 1/3 arctangent of basically 0, right? Yeah, I have no idea why they did this crazy method. Ours totally works. Okay, and I noticed the answer key said tangent inverse. I know somebody asked me about this one yesterday. When you see arctangent and tangent inverse, those are interchangeable notations. It's just, it was one mathematician did it one way, one mathematician did it another, and we never dropped one or the other. They kept them both, okay? All right, let's talk about arctangent of 0. All right, that piece right there. Arctangent of 0 is, we remember where our sine divided by our cosine is equal to 0. So sine divided by cosine would be equal to 0 right at 0, right? Because that would be 0 over 1. Arctangent, remember, is only valid between negative pi over 2 and pi over 2. So that's why I only use this one and I don't use the pi, okay, on the other branch. So this is gone basically, isn't it? That turned into 0. So now I'm going to go ahead and plug in my infinity. So 1/3 arctangent of infinity over 3. What's infinity over 3 equal to? Not 0. Infinity, right? Because I've got a giant number divided by a tiny little 3. It's still infinity. Okay. So arctangent of infinity was something that we learned that we're probably just going to have to memorize. We learned it as we were doing this unit. Does anybody remember what it is? Good job. And then pi over 2, 1/3 times pi over 2 would be pi over 6. I don't know why. Because I totally borrowed the answer key from the resource I got this from. I don't know why they did the crazy method. So you do not have to do the crazy method. Do ours. It was way easier. They were replacing all kinds of stuff, and it was crazy. They turned it into like the second fundamental theorem where there's a chain rule. Why would we add extra work if we don't have to? All right, were there any others of those ones that you were confused about that you needed help on from the little partner quiz yesterday? Number one? Okay. Okay, there's that. Let me erase this. Okay, let's go to number 1. All right, so I tried to give you some ones that we didn't see in the other stuff. This was one of them. So when I see something like that, okay, especially what if I gave it to you multiple choice, like the EP Classroom ones, and I saw somewhere in there was maybe one natural log, not multiple natural logs, but maybe just one natural log at the end. That means I'm going to do long division. The other thing to notice, recognize long division is see how my numerator exponent is higher than my denominator exponent? That's another indicator of long division, okay? So first, if it's multiple choice, check your answers. If there's one natural log, try long division. If there's multiple natural logs, it's probably partial fractions, okay? And then again, higher exponent on the top, then use long division. So that's where we're going to start. Let's do some long division. All right, so we've got 50x cubed minus 55x squared minus 26x plus 33. The upside of the way that we're doing things this year and the way that I've done in the past, when I used to give the Unit 6 test, we'd do all this stuff and then I'd make a bunch of them U substitution and then they did no U substitution on the test. That's why I have the purple sign that says always try U substitution first. So this time you're guaranteed you're going to get one that's long division. You're going to get one that's completing the square. You're going to get one that's partial fractions. You're going to get one that's, I don't know, what else did we do? Integration by parts, okay? So there'll definitely be one of each type. All right, so you got to make sure you know all your types.
Is there integration by parts
on this?
Oh, yeah.
Yeah, there's one on there.
There was?
Yeah. I think the guy used the tabular method on it.
Oh, okay.
Yeah, so tabular method and integration by parts are the same thing.
So we can use either?
You can use either one. Doesn't matter. So if you like tabular, it works for every problem, okay? It works really well for the problems that cycle, the cosine, the sine, and the e. That's the best route for those, okay? Yeah.
Do you want like number 2?
Number 2, probably not. I just threw that one in there. So number 2 with the 2 to the x, I decided we needed 6 problems, and I threw that one in there. I'm like, oh, that looks good, and you got to just memorize that extra integral, right? So, but no, I won't put number 2 on the test. Okay, that wasn't really part of what we were doing this time. Okay, let's go ahead and try this. So, how many times does 10x divide 50x cubed? 5x squared. Good. Okay, and then I'm going to distribute that through. So I would get 50x cubed. 5x squared times negative 7 is what? Negative 35x squared. Okay, and then I need a totally different color because that one is not going to work very well. Let's try teal. Okay. Oh, now I lost my blue. That's no good. All right, I'm going to change my signs. Okay. Can I blow this up? Will it let me? Oh, there we go. That's a little bigger. Okay, the 50x cubes cancel. That's what we planned. Negative 55x squared and positive 35 is what? Negative 20x squared, and then I'm going to drop the negative 26, so negative 26x. All right. How many times does 10x divide negative 20x? Negative 4x, right? Because we got to get to an x squared. I missed saying the x squared part. Negative 2. Why did we do negative 4?
Because I was looking at my answer.
Oh, okay. Got it. It's all right. No, it's okay. It's our brains growing, right? So my brain grew really, really big the other day. I called the kid by the wrong name. There was like dead silence in the room. And then I'm like, no, it's this name. And I felt stupid. It's okay. All right, I'm going to distribute that through. So negative 20x squared. And then negative 2x times negative 7 is what? 14x. Okay. And then we got to find my, I guess we'll go purple. Okay. And then I'm going to change my signs. All right. My 20x squareds go away. That's what we planned. What's negative 26 and positive or negative 14? Good. And then we're going to drop down the 33 at the same time. So what times 10x is negative 40x? Yeah, there's the negative 4. Okay, I'm going to distribute that through. Negative 40x and then 28. Is that right? Yeah. Okay. I don't know. We'll go green, I guess. All right. And then I'm going to swap my signs. So 33 minus 28. 5. Good. That's our remainder. It would go over the top of whatever we had here. I think that's probably worse than the actual integration. Though there is going to be a little bit of a trick in the integrating the last piece there. Okay.
Could you go back to the when you distributed the negative 2x?
When I distribute the negative 2x, yeah. So that was this color, right? So negative 2x, and then it's going to be negative 2 times 10x is negative 20x. And then negative 2 times, I'm in the wrong line. Hang on. Let me use a different color so we can trace it. Okay, so it's this times this is negative 20, which we had we swapped our signs there. Okay. And then negative 2 times negative 7 was positive 14. And then we went through and we changed this to a plus and this to a minus on our subtractions. Are we good, Marilyn?
Yeah.
Okay. Okay, we ready to integrate? Okay, so here comes the integration. So we've got the integral of 5x squared minus 2x minus 4 plus, I'm going to go ahead and move the 5 out front, 1 over, actually I'm going to leave the 5 inside. So 5 over 10x minus 7 dx. I don't know why I wrote a separate integral symbol. Actually, I do. It's going to, because we have to do a u sub right there, right? So let's just split it now. Doesn't matter one way or the other. Make a plus sign in there. All right. First part, easy peasy, right? What's the integral of 5x squared? Good. And then the integral of negative 2x. 2x squared over 2, which those would cancel, right? And then the integration of negative 4. Good. All right. This back piece, it's got a u sub hiding in there, right? Oh, look, orange. Okay. So here's our nice little u. 10x minus 7. So what's du equal to? It's going to be equal. I don't have the right colors. We're just going to go with orange. 10 dx. Oh, that's purple. Okay. So technically, okay, I do have part of the 10, don't I? I have the 5. So what do I really need to add in? 2. So I need to add a 2 in here and a 1/2 out here. if you did the 10 and the 1/10, that's fine. It's just you're going to have to simplify something at the end, especially if this was like a multiple choice. Okay. All right. I'm going to do the u sub without writing down the u sub then. Okay. So 1/2. I'm not messing with any of this. The 2 and the 5, remember, these were the 10. So that's just going away. That was the du part. So I would have the natural log of the absolute value of u, which is the 10x minus 7. And then what goes at the end? Plus c. So the only other thing we could do to make it prettier would be to erase the 2 right there. And then that would be the final answer. Okay.
We go over
Number 3? Sure. All right, everybody good with that one? Okay. Let's look at number 3. All right, so number 3, it could go one of two ways, right? First thing I would probably want to try is partial fractions, right? But does it factor? No. So if it doesn't factor, then kind of your last resort is completing the square. All right. So let's go with completing the square on this one. When I do completing the square, I'm going to always move that third term. Okay, so it's a little different than the completing the square we did in Algebra 2 or pre-calc. Okay. So I'm going to leave a blank. Okay, and I'm going to go plus 2, and I'm going to leave another blank. I am going to set up, I always set up my next line before, when I'm doing completing the square, before I start the process. So I have somewhere for my work to go. I know it's going to be x something squared, because remember, whatever I get here technically factors into this. Okay, but we're just cheating on the factoring part. We're going to do it as we go. Okay, so to complete the square, I need to do what with this middle term? Divide it by 2. What do you get? So positive 1. And then the hint's right here. What do I do to that positive 1? Square it. What do I get when I square it? We're going to add 1. If I add 1, I also have to subtract 1. This is, remember in our notes, it was titled adding 0. That was adding 0. So adding 0 is completing the square. Okay. All right. I also need to put these two together here. So what is negative 2 plus 1? Or sorry, negative 2 minus 1. I'm sorry, 2 minus 1.
1.
There we go, 1. Okay. And then dx. Oh, what did I do? Oh my goodness. It must be Friday. Let's try that again. Plus 1 dx. All right. Now, what kind of integration do I need? Yeah. So remember on the last one, we started with long division, but we ended up using u sub and natural logs, right? This one we started with completing the square, but when we got it down to integrate it, it's going to be an arc something. Okay. Arctangent goes really well with completing the square, doesn't it? Completing the square just set that up perfectly for arctan. Okay, so you know if you end up doing completing the square, it's probably going to be an arctan. Marilyn, what's wrong?
So you got the plus 1 from here? The 2 minus
Yeah.
Oh, okay.
Does that make sense where I kind of color coded it there? Okay. All right. So what is the u part of this arctan? Good. The x plus 1. And then what's the a part? The 1. Good. All right. So let's go arctan. So we're going to say arctan is 1 over a. So what's my a value? 1. Don't really need to write that down. Arctangent of u, the x plus 1 over the a1 plus what at the end? C. So we could say arctangent of x plus 1 plus c. Yeah.
Could we just do completing the square in the way we learned in algebra? Or no?
What did we do that was different?
Well, because I feel like that one confused me more than yesterday. I just did the thing where you move the c over.
Move it to the other side?
Yeah.
I wouldn't do that embedded in your work here, right? Because you don't have an equal sign in there. Okay. But you can, right? If you did some side work off to the side and you said that you took the 2 and you moved it to the other side, right? Plus 2x, and then you added a blank here and added a blank here. In that case, you add the same number to both sides, right? So we add 1, we add 1. So that would give us -1 here, and then we would have had our same divide by 2 and square it thing, and then move it over. It's +1 squared +1. So it gets the same. If you want to do that, that's fine. Just don't put it in the middle of the work. Okay, it needs to be like side scratch work. Does that make sense?
But like that would still work.
Yeah, that still works. It's the same thing. Okay. So it's either you do add 1, subtract 1, or you can. This is the way I teach it totally in Algebra 2. Okay. Because the only time we use completing the square in Algebra 2 is when we're solving quadratic equations or trying to get it into vertex form. Okay. But we don't use it in this context. Right. And then we don't see it much. I guess we should have really seen it in AB, but you don't use it a whole lot. And then, it appears here. Okay. Any other questions on that one? We good on that one? You want to do 5? Yeah. I'm gonna do 5. All I planned for today was questions, so we're good with. Are you telling me we're good with parts? We're good with number 4. We like integration by parts. Just don't fall into the trap and try to integrate everything by parts. It doesn't work. Okay. All right. It's good that we got integration by parts down. All right. So we got to do partial fractions, right? That's the place we want to start. How do we know if it's partial fractions? It factors, right? Could there be some junk more than just a 1 in the numerator and have partial fractions? Could I put like a 2x up there and still have some partial fractions going on? Yeah. Okay. So it might not just be a 1 on the quiz. It might be something else. All right. But this will give us at least some good practice. Oh, this one had a crazy ending, huh? All right. So what did you guys get when you factored it? Because I'm assuming you got that part. X plus 4, x plus 2. Perfect. All right. So I'm going to rewrite that as a over x plus 4 plus b over x plus 2 dx. I'm going to give myself another line, so I'm setting up for later. This is me just planning. And then I'm going to go one more line because I know that's going to be my answer, and then that way I've got space to do the bulk of the work here. Okay? All right, so I am going to multiply by what is missing. That is a shortcut, right? Really what we are doing is we're multiplying everything by this and canceling something, okay? But we just multiply by what's missing as a shortcut. I start by writing down 1 equals. All right, what should I multiply this one by? Good. So I'm going to distribute the a. I get ax plus 2a. What do I multiply the b by? Good. So I get plus bx plus 4b. All right, so now I know I have, how many x's do I have on the left side? 0 x's plus 1. So I have an equation that's 0 for the x, and then a and b. So a plus b. Then I have an equation that's 1 equals 2a plus 4b. Okay, do you want to use substitution or elimination? Elimination? Okay, do we want to eliminate the a or the b? A. Okay, so that means I have to multiply this by what? -2, which I kind of don't have space, but that's okay. All right, so we've got 0 equals -2a minus 2b. All right, what's 1? Is 1 plus 0? 1. 2a's cancel. What's 4b minus 2b? 2b. All right, and then we're going to do what? Divide. Good. All right, so we know our b is 1/2. I'm just going to go throw that over here. I got to get a. So I'm going to plug back into this one. So we have a plus 1/2. A equals -1/2. Okay. So I'm going to put the -1/2 here. All right. Do I really have to worry about those 1/2 at this point? Aren't those just going to float out and be coefficients in front? So I'm just going to, as I'm doing it, I'm going to float them coefficients in front. So I'm ignoring the 1/2. So really there's a 1 upstairs. Do we need to worry about U substitution on this one? No, it's always there, right? But because our du would be dx, we don't need to use it. So I'm just going to, when I integrate 1 over some mess, what do I get? Natural log of whatever the mess is, right? Absolute value of the mess, plus 1/2 natural log absolute value of the mess, plus c. Perfectly good answer. But what if that doesn't show up if it was multiple choice? Okay, so now comes the logarithmic algebra we have not seen in a while. Probably the first thing I would do is go ahead and factor that 1/2 out. So I'm going to pull the 1/2 out front because it's greatest common factor. At the same time, I'm going to swap the order of these things. So it's natural log absolute value of x plus 2 minus natural log absolute value of x plus 4. And then still plus c at the end. I'll give you a minute to catch up. I'm going to go one more line. Okay, in the log world, what does subtraction turn into? Division. Good. So 1/2 natural log absolute value of x plus 2 over x plus 4 plus c. It's one of those things where it depends on who authors the question, okay, and where they decide to stop. If this was open-ended on the quiz, you have my permission to stop here. If it's multiple choice, you have to go with whatever the multiple choice is. So if that doesn't show up, think, oh, I might have to do some log properties here. But again, that's algebra, not calculus. The calculus is in the starred line right there. All right. I think we did almost all of them, right? We skipped over the 2 we knew how to do. All right. Is there anything else from anywhere else that you want me to talk about?
Can we practice like the limit when it's like instead of infinity, it's number?
Yeah. Let's see if we can find one of those. Let's see if I can just pull. Oh, no, I don't want to do that because I don't have the answers to that necessarily. Let's pull. There was a worksheet that went with it, right? Did I give you guys a Mr. Record worksheet? Probably. Oh, did I give you Delta Math on that one? Or AP Classroom? Okay, let's try. Wait a second to see if. Oh, that's gonna make it tiny. Sorry. I'm just gonna make one up. That's not a very good idea, but I'm just gonna try it. Okay. So let me find just a blank spot. That one's kind of blank. Okay. I gotta have something darker. There we go. Okay, so we've got the what am I doing? That's a drawing tool. All right. Let's see if it'll erase that. All right, so let's say I have the integral of 1, or let's not do 1. Let's do let's put a number there. We'll go 4 over, let's go 1 minus x from 1 to, I don't know, let's say 6 dx. Okay, so look at the domain right now. And I have no idea how this is going to turn out because I just made it up, right? If I look at that domain, because your domain is your 1 to 6, right? What would make my denominator equal to 0 right now? 1. So when you see that happening, that's an infinite discontinuity, all right? That means that I have an improper integral because it's basically going to be an asymptote at 1. The graph's going to probably look, along these lines. It's not exactly this, but it's going to be one of these ones that looks like split like that, and somewhere there's an asymptote. Okay, in this case, the asymptote's at 1. So it's either going up to infinity or down to infinity, depending upon how it gets tilted. Okay. But that's the idea of what's going on. So when I recognize that, because they're not going to give you the graph, probably not going to have your calculator right on a problem like this on the AP test. So you have to always double check to see if you get a 0 when you put one of them into the denominator. Okay. All right. Let's try it. So we're going to go the limit as b approaches or not infinity this time. As b approaches 1. So we're going to go b. And if you want to use a, you want to use b, you want to use q, it doesn't matter. It's just a variable. Okay.
This is called an
Improper integral. Where this leads, you guys, is it goes into this is kind of our first dip in the toe, dipping our toe into the water into unit 10. Unit 10 is the big one that's tough. Okay. It's not that tough, but this is kind of the first baby step into that, the first time you see it. All right. So now I'm going to integrate like I always would. Okay. What do I see that I'm going to have to do? Okay, it's going to be a natural log, but what do I have to be careful about? Is there a coefficient in front of our x? There's a -1 in here, right? So technically, totally in the wrong color, I have a u sub, right? So I would need to put a negative on the inside and a negative on the outside. All right, so now I'm going to do the rest of the u subbing in my head. If you're struggling with the in your head, it's okay. You can still write out your u sub. Okay. So I've got negative just going on. I'm going to have that 4, and that 4 really we could have put outside. So it's still a -4. This negative on the inside doesn't get to come with it. Okay. Natural log, absolute value of the mess on the inside from b to 6. Okay, so now I'm going to go ahead and plug in my 6 and my b. So I have the limit as b approaches 1, -4, natural log, absolute value of 1 minus 6, which I totally screwed that up because I don't think we can do natural log necessarily of a negative. So we're going to change this to like a 7. How's that sound? This is what we get when Mrs. Ballard makes up the problem. Oh, good. I just made it 0, didn't I? That's okay. We need to practice that too. -4, natural log, absolute value of 7 minus b. Oh, no, that totally screwed it up, didn't it? I have to have the 1, don't I? All right, so I did a really bad problem because I can't change that because we had to have the 1 to have the infinite discontinuity. So, my bad. All right. Carlos, what were you commenting? Was that what your comment was?
If it's like the absolute value, it doesn't matter if it's negative.
That's true. You're right. It doesn't matter if it's negative or positive. Thank you. My brain was not working there for a second. Okay. So 1 minus 6. So this is just, this first part is going to be -4 natural log, absolute value of -5, which would be 5. It's just going to be a mess like that. Okay. The second part, the problem is I cannot put that 1 in there. Okay, so I need to know what's going on close. I think when we did one on the AP Classroom, it canceled out like the first part. It ended up being like the natural log of 1, which is 0. And then what we have to do is you have to look at what's going on really close to this to see what's happening. Okay. It really should be going to either positive or negative infinity is what's going to happen on something like this. Okay. So let's think about this. If I'm supposed to be on a number line, right? I'm between 1 and 6, which means I really need to look at what's going on to the right of 1. So something that's getting close to the right of 1 would be like 1.5 or 1 and 1/2. And then I could get like 1.9 and 1.99. And so remember when we did the tables with limits way back in AB, like at the very beginning of the year? That's kind of the idea. Okay. So let me show you the idea. I'm just going to pull Desmos out really quick and show you the idea. And then all right, so it would be, we had 1 over 1 minus x, right? Oh, and I need to say f of x equals. You can start seeing it already in that graph. All right, so I'm going to find f of 1.5. It's negative 2. Now I'm going to find f of 1.9. Notice it's negative 1.111111, right? F of 1.99. Going to 1, isn't it? What's going on? Something doesn't seem to be going right. F of 1.99999. If I keep adding 9s, it looks like it's going to negative, or it looks like it's going to negative 1. That's not what it should be doing. It should be going to an asymptote. What did I do wrong? Where's Cami? As we are approaching 1 from the right side, it should be going to, because if I look at the graph, where did Desmos go? I look at the graph, negative or 1 from the right side should be going down to infinity. Oh, I know what I'm doing wrong. It shouldn't be, I'm going the wrong direction. 1.9 is bigger, isn't it? I should be doing this. There we go. See what I did wrong? Pick the wrong number. Well, I'll go back and explain it. Okay, let me go back here and explain it. Okay, I was counting wrong. It's rough when the calculus is right and the counting is wrong. Okay, let's think about this again. Okay, so as I'm getting close to 1 from the right, okay, so I know that I would have like 2, right? And then close to 2 is 1.9, close to that's 1.5, close to 1 is 1.1, right? Or 1, and I can get closer by doing this and by just adding zeros in front. Okay? Well, look at what happens in Desmos when I add zeros in front. Oops, I can't make that bigger. Do you see how when I did 0.01, I got negative 100, and then I got negative 1,000, and I got negative 100,000? It's growing astronomically fast when I'm doing a very small x. So when I see that happening, that means it's going to infinity. In this case, it's going to negative infinity. So that means that this part is going to, this whole chunk back here is negative infinity. So overall, on one like this, sorry, it's go away. This whole piece, no matter if I add this to this, I'm still going to get negative infinity. Would that converge or diverge? Yeah, so therefore it diverges.
What type of problem is the one that's most tested?
Which one's most tested? It could be any of them. Probably more likely to be the other one with the infinity on it, but as soon as I say that, you'll see one of these for sure. So we're technically responsible for both. It has been trending a little bit more than they put in improper integral and free response a little bit more lately. Not much. It's like one part of one question, but sometimes it appears there. It would a lot more likely in multiple choice. Okay.
When the domain just has like numbers, like no infinity, is it always gonna diverge?
I don't know off the top of my head, but it might be. Okay. It always seems to, doesn't it? Yeah, but you got to prove it to me. Okay. When we hit this situation, though, don't we always hit infinity? Whenever we have that situation going on, because remember, you're going to have to know this without using a calculator at some point. Okay. So when you see that situation going on, you start thinking, oh, wait, this is the one where we plugged in the goofy stuff and it always went to infinity. Okay. So probably they always do diverge. I don't know, though. I haven't experimented with it that much to tell you one way or the other.
So you're trying to like get close to 1.
Yes, we're trying to get close to 1 because if I put 1 in there, I can't take the natural log of 0. Okay. It does go undefined. And in theory, yeah, it probably does diverge. Okay. All right. Is there any other questions that we have?
Number 9 is
From AP Classroom?
yeah.
Okay.
Because it would just be
Okay, let me get there. It'll take me a minute to get there. Otis. Not Otis. AP Classroom.
One of those six questions I had to avoid that. One of them was like this, but it was positive.
Let's see. Okay, progress check C. You said it was number 9?
Yeah.
Okay. It's spinning right now. Oop, too far. Okay. Well, this looks crazy. All right, so which of the following statements is true? I'm not going to be able to, I didn't do the PDF copy, so I'm just kind of, so hopefully you're looking at number 9. It gives you the antiderivative of a crazy function, or of a function. They actually tell you the answer, huh? Which of the following statements about the integral is true? All right. So, okay. The integral equals, the integral equals, the integral diverges. Okay. All right, so we got it. It's basically manipulating the algebra on this one. Okay, so here's some blank. Let me try to get it up there. So the key is recognizing that we have, so they tell you sine x over 1 plus cosine x. It says is. Is means equals in math, right? The negative natural log of 1 plus cosine x, and there's another word that I was missing, so I got to fix that. Cosine x. It says the antiderivative of. So if this is the antiderivative, to get to it, we integrated this. Okay. So which of the following statements is true about the integral? So, and remember that, and they told us the integral went from 0 to pi. Okay. If we cosine of, okay, so that's the problem right there. It's an improper integral. So let's look at y. Okay. Our coordinate right here on unit circle would be negative 1, 0, meaning the cosine is equal to negative 1. So if I look at this denominator and I'm looking at it at pi, right, it would be 1 minus 1, which gets us what? 0. So do you see where the improper integration comes in? It's that top value. Okay. All right. So that means I would have to talk about the limit as, what did they say? They just went with x. As x approaches, we've been using a and b. Okay. They went to an x. As x approaches pi, okay, from 0 to, I think they just went, oh, they didn't even do that part. They're saying, okay, I'm just going to go 0 to x because that's what I used. All right, so I've got to do this piece here, okay? And do you notice how, because the AP Classroom put a left-right thing on it, because it's at the top, that means we're approaching it from the left side of it. Okay, let's talk about that part. If I'm on a number line, I'm going from 0 to pi, and I have to be in between here. If I'm coming from this direction, that's to the left of pi. So that's why they put the little negative symbol, or the left side symbol on it. Okay. All right, so we know that we're working on that part of this mess on this side. And if I think of this as an equation, Whatever I do to the left side of the equation, I have to do to the right side of the equation. So I'm also going to take the limit as x approaches pi from the left of negative natural log of 1 plus cosine x. I'm going to erase this mess over here that we were scribbling in. Okay. And then we have to, so if we tried to find this limit of this over here, okay, let's see if we can mess with that. Let's see, if I put pi in there, I would get negative natural log of 1 plus cosine of pi. What's the cosine of pi? Negative 1. Okay, well, so I have 1 minus 1, so we get negative natural log of 0. Does that exist? No. Okay, so it does not exist. So that's why it was the last answer. So so it diverges. So look at this. So we just proved what we were talking about before, that if we got that, if we get this natural log of 0, maybe we don't have to do the mess I was going through before. All we have to do is it doesn't exist, so it diverges. So I've been doing it the long way. Okay. It's D, correct. Yeah. Okay. I didn't need to because whatever I do they already told me the antiderivative. They gave it to me. So they gave me the antiderivative on the right. They said this thing is equal to this thing. And so what I did was I set them equal to each other, and then I knew it had to be an improper integral, so I took the limit, whatever I did to the left, I did to the right. So that's why I took the limit of both sides. Are we okay, Erica? I wouldn't panic about being ready for that one on Monday, okay? Okay.
Because I did get undefined.
Uh-huh. You plugged in.
So they just gave us that, so I just wanted to say it.
Yeah. You too, kiddo. I only went with the way they did it, so it's possible that maybe you can't do it that way and it works. Okay, so.
But if this is just undefined, then you would disregard this one.
Yeah, because that's basically that. See, that's the hard part about why this is more definitive, because we know for sure it came out undefined. Okay, so that's why this is a little bit sketchy. Okay, makes sense. Yeah, I probably wouldn't do this to you on a test. Okay.
Okay.
It's always good to look at because we want to be ready for them to throw us weird things on the AP test. Okay. But we're just trying to make sure you understand this stuff, not that you understand it for AP test yet. Okay? No, what we've done, so basically the progress check and what we did yesterday. Okay, so we do those a couple of times. Oh my goodness. All right. And then they walked away. Okay. All right. So yeah, try to do those two things. Okay, a couple times. Okay. Focusing on making sure you can do a completing the square, completing the square, long division, parts, partial fractions, improper integral. Got it. That's what we got to be able to do. Okay.
Thank you. And this for 11? Because it's just how it's equivalent. I saw
which of the following is equivalent to. It's going to be a complete the square kind of thing, I think. Let's look and see what they did real quick, so I don't lead us down the wrong path fast. It's partial fractions.
Yeah, that's what I did.
Okay.
But I don't know which one is equivalent.
It's supposed to come out to be D. It is basically what I would do with that is I would just do your partial fractions. I would just ignore this, solve the partial fraction.
No, it's because they were flipped. I did.
Oh, you did it?
Yeah.
You can flip the answer around and just make sure this negative has to stay with this one. So as long as, it's D.
Okay.
Okay?
Thank you.
You're welcome. Okay, I gotta stop recording this.